Alright, so more target 3 practice. This first problem is all about combining rules to find a derivative. You got a couple options. We'll go with, let's say I treat cosine x as one function, and then x squared sine x as another function, right? So I'm identifying it that way just so I'm going to go ahead and use the product rule to start. So you know the yellow times the derivative of blue plus the blue times the derivative of the yellow piece. But I'll try to write it out step by step. So yellow is your cosine x, and then you're going to go derivative of the blue. And if you're looking at the derivative of the blue, I hope you're thinking that you're going to need quotient rule for that piece. And then derivative of the yellow times the blue. So, once you get this first step, then all the work has to go into this and this. But that one in purple isn't bad. I mean, the derivative of cosine x is negative sine x. So we'll just do a quick rewrite. We're going to leave this piece since that's going to take some work. And we'll put this one in. Okay, so derivative of cosine is negative sine x, which is going to work out kind of nice because this piece here you can simplify pretty easily, right? I mean, the sine x over sine x cancels and you just got a minus x squared. So we're not home free, but we're closer. We're closer. So now you got quotient rule on that piece in blue. So whatever that blue thing turns into, I'm going to put it in parentheses. So I don't want to lose the fact that whatever that turns into, I have to distribute cosine x to it. So let's say I got low d high minus high d low all over low squared. So now you got, just clean this thing up, right? So that blue piece is now sitting here. You can just simplify it a little. So let's see, you got 2x sine x minus x squared cosine x. So nothing really to simplify. And then sine x squared. It's all of that times cosine x. And minus x squared. So I'm going to stop that there, and that's my y prime. Right, that's my answer to the first one. Second problem, you're going to start with y equals quantity 4x to the 2x squared plus 5x. Now it's not until I ask you for y prime that you should be thinking, oh, I need logarithmic differentiation. But I've given you a function, right, and it's in the form function to a function, so you need logarithmic differentiation. So natural log both sides. Alright, so no calculus going on here. You're just doing a little pre-calculus trickery. So this is going to allow us to rewrite the right-hand side. 2x squared plus 5x times the natural log of 4x, just properties of logarithms. No calculus yet, but the next step we're going to take the derivative of both sides with respect to x. So since you're taking it with respect to x, natural log of y will turn into 1 over y prime. Right side you're going to need the product rule, 2x squared plus 5x times the derivative of natural log of 4x plus, so product rule, 2x, derivative of 2x squared plus 5x, and just times the natural log of 4x. Okay, clean this up a little. You need to take care of that one, you need to take care of that one. Not so bad. The first one, you got some chain rule, the second one you don't. So 1 over y prime equals 2x squared plus 5x times, let's see, two functions, outer, inner. So outer is my 1 over 4x. My inner derivative of 4x is 4. Okay, this is just a little power rule. So 4x plus 5 times the natural log of 4x. Clean it up, multiply both sides by y. So 4 over 4x, that's just 1 over x. So the left side you got 2x squared plus 5x over x. That could be cleaned up more. Plus 4x plus 5 times the natural log of 4x. And you got y prime equals that times y. So I got a last step, be to write out what y equals, and you go back to the beginning of the problem to figure out what y equals. But I see this right here, and I might as well simplify that. So that's x times 2x plus 5 over x. So that is just 2x plus 5. So when I do my rewrite, what I've put in a box there in purple, I'm just going to replace that with 2x plus 5. So y prime equals 2x plus 5 plus quantity 4x plus 5 times the natural log of 4x times y, which was 4x raised to the 2x squared plus 5x. So there you go. That's y prime. Right there. One more problem to go for the practice. Little implicit differentiation. So I give you the relation sine of y plus xy minus 4x equals y. The goal is to find y prime. If you could, you'd isolate y before you differentiated both sides, but you can't. There's just too much going on there. That's fine. Y doesn't have to be isolated for you to take the derivative of both sides. So I start and I say, well, how many terms do I have? I've got 1, 2, 3, 4 terms. So you'll just take the derivative of each side, which ends up being each term. So start with the sine y term. You're taking the derivative of both sides with respect to x. So if you're taking the derivative with respect to x and you come across y, the derivative of y with respect to x is y prime. Over here, though, derivative of the sine of y with respect to x, you need to see that that's two functions. This is chain rule. The outer is sine, the inner is y. Why am I treating y as a function? Well, because you're taking the derivative with respect to x. So the derivative of the outer, derivative of sine is cosine. So outer at the inner times the derivative of the inner. Plus, okay, a product of x times y. So product rule. X, y prime plus 1 times y. And then minus derivative of 4x is just with respect to x is 4. So I've got 1, 2, 3 terms with y prime in them, and 2 without. So I gather all the ones with y prime. I'm going to put them on the left. Cosine of y times y prime plus xy prime minus y prime equals 4 minus y. Factor out the y prime. Cosine y plus x minus 1. It's 4 minus y. And then divide both sides by that quantity and you got y prime isolated. 4 minus y is cosine of y plus x minus 1. And that, my calculus friends, is the answer. Assuming I didn't make any mistakes. Alright, good job.